Okay, hello. So I am Takahiro, and with Shinji, Daichi, and Graham, we are working on lexicon learning. So yeah, not this one. So our goal is to make an open vocabulary automatic speech recognition system that can recognize and learn unknown words. And we also want the learning very flexible, combining any type of available data. And our approach for this program is to introduce a Pitman-Yo lexicon model and integrate this one to a monolithic Bayesian speech recognition system. And so in existing current automatic speech recognition system, pronunciations of all words must be prepared beforehand. If unknown words appear in the input speech utterance, then decoders try to assign one of known words, and it produces recognition error. However, it is not easy to actually mostly impossible to prepare lexicon that cover all the words. And even if you once obtained a lexicon that covers all the words, as a nature of language, new words are invented daily, so this becomes an old way. And due to this, currently continuous human-based maintenance is required, and this is not good. And we want to make the speech recognition system more self-standing. So the difficulty of pronunciation dictionary depends on language. For phonogram language like Turkish, the mapping from phoneme to grapheme is kind of quite have a strong correlation, as Mirko said. And for ideogram like Chinese, in this case, the relation is quite weak. So basically, you need to remember pronunciation for word for each word. And some languages are middle. And for this kind of language, grapheme to phoneme approach is most suitable. And we in this subgroup, we are working for this part, the lexicon-based approach. And this approach and this approach is kind of a different direction, but they are not exclusive. They could be combined in the future. So when we say out of vocabulary in speech recognition, there are actually two types. The first one is spelling is known, but the pronunciation is not known. And the second type is both spelling and pronunciation is not known. It only appears in speech data. And for the first type, this is a situation like you got a large amount of text data from the internet, and you have a partially pronunciation dictionary made by manually. And so this is very realistic situation. And in this case, if you are given a phonetic transcript and a word alignment of known words, then you could guess what kind of, here, these are unknown word segment. And you can guess what kind of words will appear here. You can consider the context and predict what kind of words likely appear to here. And if the word appears several places, then you could use that information as well. And we want to formulate this principle in a way of Bayesian approach. So this is our proposed Pitman-Yo process-based pronunciation dictionary. Here, this is a vocabulary. This could be finite or infinite. And we assign a Chinese restaurant process for each word. So this node corresponds to a word in a vocabulary, and we assign a CLP to each of them. And here the customer is the appearance of an pronunciation. So usually words have only a few pronunciations. So we set the hyperparameter representing concentration close to 0 so that only few pronunciation is generated. And as a base measure, we can use phone n-gram or something like that. The draw from this distribution is a pronunciation. This is shared among the Chinese these words, but each word has its own CRP. So to train the model, we want to flexibly use various types of data, like word sequence or acoustic sequence, or kind of phone sequence or segmented phone sequence. And to do that, we integrate the proposed lexicon model, Pitman model, process-based pronunciation model, into a huge single monolithic Bayesian speech recognition system written here. So in this figure, these nodes are decoding chain. This is the acoustic input, and this is a word sequence output. So in usual speech recognition, this is input as a speech input, and do some probabilistic inference and output the word sequence. And this node corresponds to probabilistic model using speech recognition. And this part is a pronunciation dictionary. When a training data is given, it is injected into some of the layer which correspond to the data type. And the most easiest case is where the word sequence and the segmented phone sequence are given in an aligned form, like this. And by considering the conditional independence structure of this probabilistic model, in this case, you can ignore all of them, and you just need to consider this part. And more concretely, this is a situation. You are given a word sequence and aligned word segmented phone sequence. So in this case, it's just trivial to find the pronunciation. Because you have a segment, you can easily find the correspondence. So this is a trivial case. And okay, so this is a more general case. And in this case, language model and phone sequence and part of the pronunciation dictionary is given. And in this case, decoder must be handle this situation. This is a very preliminary experiment that we just obtained this morning. And this is the initial iteration. And we got some improvement here. But this is kind of a champion data using very small amount of data, and we need to increase the data to and continue the experiment. So in summary, we proposed a PY lexicon model for pronunciation dictionary learning and implemented a prototype WFST-based full Bayesian system and running some initial experiment. And so more concrete system requires more computation, and Daiki is working on to this part. Yeah, thank you.